So now I probably should have covered this circuit before the last one. The last one we switched this with an NPN bipolar junction transistor, but I already built this diagram. We'll go over this. So we're going to simulate a 12 volt lithium iron phosphate battery right there. They commonly come in a 12 volt version and usually pretty large, but in any case they come in about any size. You just series the cells until you get a voltage you want. And then larger cells, of course, can carry more power in them, store more charge. But in any case, we have our circuit here. The reason why we got a couple resistors is the voltage we're working with. A single resistor, if it was 940 ohms, but usually you use 1,000 ohms, getting basically the same result. But a single resistor would get too hot. So wattage is the voltage across a component and the current going through it. So we're setting the current the same through all of these components here, and but the voltage will get split up. So the LED is going to drop about 2 volts. If we have a charger applied, we can expect up to about 14.6 volts across the battery. So we'd also have like a charger applied to it as well, and the charger would be powering the circuit for the most part. But that's what we could expect. Could go across any circuit that we attach to a 12 volt lithium iron phosphate battery, because it has a nominal voltage of 12.8. A charger can apply about 14.6 volts across it. When it's fully charged, you remove the charger, or if the charger goes into a float mode, it might go 13.6 volts. So that will be the battery resting. No current will be going in or out of it at that point. And well, it's resting unless you attach it to a load. And you can keep using it until it discharges to about 12 volts. You can really go down to about 10 volts, but 12 is a good time to stop. Below 10 is getting kind of dangerous. So we'll just look at the math really quick. You got the 2 volt drop. So when there's 14.6 applied, you can expect about 12.6 across the 2 resistors there, 940 ohms for about 0.0134 amps. Plenty to get the LED pretty bright, 13.4 milliamps of current there. But since there's 2 resistors, that means each one of them will have half that voltage across it. And of course the current's the same through all the components. So this is just one or the other resistor. Each one of them will heat up to about 0.084 watts right there. So if we used a single resistor, just keeping the math easy now, that was 190 ohms, basically 1,000. Then we would have twice the wattage you see here, 0.168. And that would be more than is desired. So most resistors are 1/4 watt. These are 1/4 watt resistors. That would be 0.168, which is below the 0.25, but you still want to stay about half of the rated wattage. So 0.125 is less than what this would be if you doubled it, 0.168. So you should use a couple. They'll stay relatively cool. I can actually touch these, and they're warm. If I held my finger there longer, I think it might cause problems. But just touching them quickly, I didn't get burned. A 1,000 ohm resistor would have hurt. A single resistor would have hurt. But yeah, we can go down to 12.6. This would be a bit less than half. It has a nominal voltage at 12.8. If you fully charge this, you get to about 12.8 volts. You're probably about halfway discharge. And then going to 12, you can see current, of course, is going to go down. We're using resistance, so now we're going to have about 10 volts across those 2 resistors instead of 12.6. But you can see LED is still pretty bright. Somewhere around about 10 milliamps of current is flowing through. So we can adjust that. So in any case, yeah, that was the main lesson of this. If wattage is going to be a problem, but if that wattage being cut in half would solve that problem, it would be within the safe range. You can just simply get the same resistance with 2 series resistors, so half the value, but just put them in series. Then they'll cut the voltage in half, and the heat they generate will also be cut in half. And I also drew out the circuit with a switch, so we will do that. I won't make a separate video. Now these push button switches. They commonly come in kits. Those top 2 pins are always connected. It's one piece of metal basically, and down there those 2 are always connected. They jump the gap pretty well with their spacing. They don't fit in the holes terribly well. You may want to modify them by bending them with pliers or something so that they fit more in line with the holes. You know, but I usually leave it the way that they are because I make these videos, so other people are going to grab them. And then you got to make sure you put the LED in the right way. We can kind of angle that so it's a little easier to see the legs. Long lead, more positive. Short lead, headed to more negative. You don't have to put series components in the order that you show. Whatever works out best, you can do. But that's short lead cathode, long lead anode. And then we got, I'll take this resistor as shorter legs. Just go one side to the LED, and I need to kind of straighten the legs on these. But yeah, there we go. So these breadboards can be kind of finicky. You don't want to really jam stuff into there. You can damage the metal. You know, just keep working, wiggling it and stuff until it slides in. So, but they're not terribly tough. But there we go. Yeah, it's on. That's 14.6 volts right there. Now we can turn it on or off. Most circuits, you'll have a way of controlling them. Just remember that whenever you see a basic circuit showing the electrical properties, you know, you actually add other stuff to it, but it's important that you realize this will be a little bit less than a half fully charged. And now basically I think it'd be 20% discharge, but it's a good time to recharge it by now at 12 volts. And so yeah, just I drew this out, so figured I would add it to this video. Doesn't really add a lot more to it, but just remember, whatever circuits I show you, they're intended to be built into bigger projects and stuff. Whenever you're looking at other people's bigger projects, I want you to understand what this basic stuff is, and then their projects are going to be showing you how you put it all together. So in any case, that's it. Thanks for watching. Make sure you check out one of the other videos I'm posting on the screen, and check out links down below. They all help out a lot. I'll see you in the next video.